All right, for these last couple of problems, we're going to talk first about displacement, velocity, and acceleration. Many years ago, I had a student that remembered kind of the order as DIVA, displacement, velocity, acceleration, like so. And the idea behind this is that we've talked a little bit about this. We use S often to represent displacement, S with respect to time, displacement. So the position of the particle with respect to time. V of t is the velocity, and a is the acceleration. We've already mentioned that the first derivative of the displacement is velocity. The rate of change of the displacement is the velocity, and the rate of change of velocity is the acceleration. Or similarly, the second derivative of displacement gives us the acceleration. So second derivative of displacement. So we've talked about this again a little bit already. The new part is speed versus velocity. So we've talked a bit about speed being the absolute value of velocity. Velocity also has direction. Speed is just a scalar measure of without direction. But we can tell whether an object is speeding up or whether it's slowing down by evaluating the acceleration and the velocity at a certain time. If the signs are the same at a certain time, then the object is speeding up. When the signs of acceleration and velocity are opposite, that means the object is slowing down. And I think this problem down below will help us understand why that's the case a little bit. So keep that in mind as we start this next problem. So we have an object is moving along a straight line so that its displacement relative to the origin is given by this equation. So we have the displacement equation, true for time greater than or equal to 0. Positions measured in centimeters, time in seconds. All right, find S prime of t and give its meaning in units. So we have S prime of t is equal to 12 minus 3t squared. And the units are, what is it, per second, centimeters per second. Okay, part B, S double prime, or that's velocity in centimeters per second, I should have said velocity. S double prime of t is negative 6t, and that is the acceleration. And that is in centimeters per second or centimeters per square second. C, at time 1, at 1 second, is the object moving forward or backward? And is it speeding up or slowing down? Well, to tell if it's moving forward or backward, we need to evaluate the velocity at that time. The velocity, if it's positive, we say it's moving forward. If the velocity is negative, we'll say it's moving backwards. So we'll find the velocity at 1. Well, velocity at 1 is the same as the first derivative of S at 1. And if you substitute 1 in there, we get 12 minus 3, which is 9 centimeters per second. And so the object is moving forward because V of 1 is greater than 0. And also to see if it's speeding up or slowing down. I can find the acceleration at 1 second, and the acceleration at 1 second is the second derivative of the displacement at 1 second, which if I substitute into part B, that gives me negative 6 centimeters per square second. And so even though it's moving to the right or forward, the acceleration is negative, and so it is slowing down. It's still moving to the right, but the acceleration is negative. It is slowing down. Those two signs are opposite. The acceleration and the velocity at 1 second are opposite, and that's what indicates to us that the object is slowing down. So I wrote slowing down because V of 1 and A of 1 have opposite signs. Opposite signs. Okay. Let's look at the next question. D. You can see it on your paper, I hope. When does the object change directions? For the object to change directions, two things have to happen. Some people just say the velocity has to be 0. Well, not just the velocity is 0. It changes directions when the velocity is 0. When velocity is equal to 0, and velocity changes signs. That tells you it's going forward and then backward, or backward and then forward. It could just be going forward, stop, and then keep going forward. And then the velocity would be 0 at a point, but it didn't change directions. And so we need v of t to be equal to 0, and we need it to change signs on either side of that time. So we're going to set the velocity equal to 0, 12 minus 3t squared. I'm going to skip some steps. When we set that equal to 0, we get t is equal to positive or negative 2. However, time must be greater than 0. Therefore, we only have a time of 2. And so to see what is actually happening at this time, let's do that sign test. I'm going to start at 0 because we start at time 0. And I'm going to see what happens to velocity on either side of 2. So the velocity before 2, if I substitute 2 in, before 2, like a 1, I have a positive velocity. After 2, like 3, if I substitute 3 into velocity, I get a negative value. And so it is moving forward for the first 2 seconds and then continues to move, but in the opposite direction, backwards from there on out. The question said, describe the position when this occurs. And so I would say that it changes directions after 2 seconds. And where is it when it changes directions? Well, to see where it is when it changes directions, we would find the position at 2. And if you substitute 2 into the position function, you'll see that it's 17. And so that is when it is 17 centimeters to the right of the origin. Centimeters to the right of its origin. And the last question, E, does say, during the first 5 seconds, at what time is the object farthest from the origin? Well, that too is quite important because I know that the velocity is positive and then goes negative. So I can see its position at 0 seconds. Its position at 0 seconds is 1. After 2 seconds, it continues to move to the right until 2 seconds, and it ends up at 17. Then it starts to move to the left. The question says, at 5 seconds, where is this, or when is it furthest from the origin? Well, I want to see what is its position at 5 seconds. And if I find the position at 5 seconds, I get negative 64. And so the answer to part E is actually at 5 seconds. The object is furthest from the origin. It is 64 units to the left. All right, and that's it for the first question. We'll do one more.